Hi everyone. So today we're going to start our work on radicals and exponents. So our first topic is going to be about square roots. Now I know we've been there, done that. So this should be a pretty, not very stressful or pretty easy topic for us. But there's some little nuances that we want to be aware of. That when we're talking about square roots, we have the principal root versus the negative root. That we're going to have to use some absolute values to indicate some things, which is going to be new for us. So there are some things that are new for us. So by the end of today, we're going to be able to simplify square roots and evaluate expressions involving square roots. So we need to remember, by what we know from previous, math discussions, that a square root comes from a number times itself. So we got to remember that the answer to a square root, let's write it this way, to a square root, can be positive or negative. Okay? So, and we're defining it as, so 5 squared, let's say, is 25. Then the square root of 25 is 5. Okay? But we also can say negative 5 squared is equal to 25. So we can also get the answer of the square root of 25 is equal to negative 5. And we're going to be the negative square root. So it's the idea of a number times itself. So remember, a square root answers the question, what number times itself gives you that number. Okay, so here's the formal definition. Number c is the square root of a if c squared equals a. So what are some square roots? So square root of 9, well, we can say 3 or negative 3. We can say 5 or negative 5. But there is no number that times itself that gives you negative 4. So this is no solution. Okay, so be aware, you can't take the square root of a negative number. And 36 is 6 and negative 6. Okay, we knew that. Okay, a lot of times we forget about the negatives though, so we have to remind ourselves. Now, how do we know if we were talking about the negative solution or the positive solution? That's when we start talking about what is called the principal root. The principal root is the positive square root, positive answer to a square root. Okay, so the principal root is the non-negative number, positive, that is the non-negative square root. The symbol square root is called the radical sign. So we call it the radical sign because you can do more than just square roots. And it's used to indicate the principal root of the number over which it appears. So when there's no sign in front of the root symbol, the radical symbol, we're going with the positive solution. So here, because there's no symbol in front of the square root, we're going to only go with the positive solution. So square root of 25, 5. Now here, there's a negative sign in front. So that tells us this is the negative 8 is our solution. Square root of 64 is 8, and then we make it negative. Okay, fractions. Okay, we're going to square root to 25. We're going to square root to 64. Okay, and we're going to get 5 over 8. So we treat it individually. All right, let's see if I can do this without shutting it off. Yes, okay. All right, so we need the square root of 0.0049. So we do have a square root symbol, second square root, 0.0049. Make sure you arrow out of there, and we get 0.07. So we can use our calculator to help us out. All right. Okay, so let me know if you have any questions so far. Now, we can have a radical expression, all right, where, I'm trying to think of a good way to put this. we can say that radical expressions, we can say the square root of a number underneath or an expression. That's the key. Okay, so we would say the square root of a. You can also call this root a, because some people refer to it as that. Or radical a. I don't usually refer to it as radical. You're going to hear me say square root or root. Okay. Now, radical expressions can, you can just have the square root of 5. And like I said, the square root of a. But you can also have the square root of y squared plus 7 all over y. Okay, that's considered a radical expression. And what's underneath the radical expression, what's underneath the radical sign is called the radicand. So in our 3 up here, 5 would be a radicand, a would be the radicand, and y squared plus 7 over y is also a radicand. Okay? Now, you're going to have 2 possible solutions when you take a square root, like we said, the positive and negative, but sometimes we're not going to get the perfects, okay? So sometimes we're going to get the perfect, like the square root of 25 against the principal root, so that's 5. But if I took the square root of 5, there is none. And we would put it in our calculator, all right? So if I said the square root of 5, we're going to get a non-terminating, non-repeating decimal, okay? So the square root of 5, we get 2.236, blah, 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 blah. That is an approximate, okay, an approximate solution. Okay, the decimal. This is the exact solution. Okay, so when it's not a perfect, we're going to want to leave it as the square root of 5, or the square root of 3, or the square root of 7, or the square root of 21. Okay, you're not going to want to find the decimal form just because we're getting beyond the approximate solutions and going for an exact representation of the solution. So we're done. When we hit the square root of 5, you don't need to pull out the decimal form. We're going to leave it as the square root of 5 because that is the exact representation of the solution. Okay? So that's important that you understand the difference between the exact solution and the approximate solution and exact representation. Okay? All right, so we're going to be able to graph the square root of x. Okay, so there's a lot happening here, so just make sure everybody's okay. All right, so let's take a second. Everybody okay with being able to find the square roots? Okay, difference between exact and approximate solutions, principal versus negative. Okay, so keep in mind we can't take the square root of a negative number. So if we're going to graph this, we're going to need to start at 0, and then we're going to talk about domain. And I'm going to be lazy here and only choose numbers that are perfect squares because I want to take the exact solution. So 1, 4, and 9. Because the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Okay, so I'm not going to pull up the grid. Okay, so we're going to graph this. Notice I'm only doing positive numbers because that's all. Okay, that's probably not. See, I can't do this without a grid. Okay. No, it is not straight. It's like a curve. Okay? So let's talk about domain. We can put in only positive numbers. Positive reals. I guess we can call it that. because you can take the square root of a decimal. You can take the square root of a fraction, okay? And our range is the same. There's something going on outside. All right, so everybody okay? We're not going to do too much with the graph. Just be aware that that's what it looks like, and we can use these numbers to graph it. All right, so when we evaluate, I know it feels like we have a bunch of different topics happening here. Okay, so we'll put it all together. We're going to evaluate just exactly the same way. Okay, and remember, if we're going to get a solution that is not a perfect, we're going to leave it as the square root of blah, blah, blah. Okay, so we're just evaluating. We're going to substitute the value into the radical. Okay, so here we have f of x is equal to the square root of 3x minus 2. Find f of 1. Remember, that means we're going to take 1. We're going to put it in here for x. So f of 1 is equal to the square root of 3 times 1 minus 2, or the square root of 3 minus 2, square root of 1. By the way, the square root of 1 is 1. People leave it that way. There is a square root of 1. Okay, so let's try this one. We're going to put 3 in for z. So g of 3 is equal to negative square root of 6 times 3 plus 4. Negative square root of 18 plus 4, negative square root of 22. That's it. We do not need the decimal, okay, unless we're asked to, okay? All right, let's find f of negative 3. So again, we're going to put negative 3 in here. So f of negative 3 is equal to the square root of 1 minus negative 3. So the square root of 1 plus 3, square root of 4, which we can do, which is 2. Again, we're only doing positive 2 because that's the principal root. Okay? All right, so let's just take a minute and make sure we're good, reviewed what we've done so far. Okay, so making sure that we know that there are two possible solutions when we're talking about square roots, the positive and the negative. We cannot take the square root of a negative number. If the square root's there but there's no sign, then we're interested in only the principal root, which is just the positive root. So if there's a negative sign out in front of the square root, we want the negative answer. All right. That expressions can be underneath your radical, which is called a radicand. You can have numbers, variables, and expressions underneath. And that you can graph the square root function by putting in perfect squares. It's going to make life a lot easier if you do. And there's a difference between perfects and approximate solutions. Remember, perfect solutions are like square root of 4 and square root of 9. Approximate solutions would be the square root of 5 when we put it in our calculator, but we want the exact solution unless otherwise told, so we're going to leave it as the square root of 5. Now, when we're taking square roots, and there's a square, like the square root of x squared or something like that, we have to be concerned if the answer is going to be positive or negative. Okay? So what we're going to be interested in doing, let me just make sure I say this right, that our answer could be positive or negative underneath the square root sign, so we have to be concerned. I just lost my train of thought. Okay, so, all right, so we have to be concerned about the value underneath. Okay, the x, the variable, the value can be negative. Okay, and that's a concern. So if we do 5 squared, okay, we get the square root of 25, which is 5. But I'm going to come over here. The square root of 0 is just 0. 0 squared is still 0, sorry. So here we get the square root of negative 5 squared. And that means square root of 25, which is also 5. Right? Notice they're the same. Okay? That what I put in is not what I got out. That's important to see. And the same here. Square root of negative 3 squared is the square root of 9, which is 3. Again, not the same as what we put in. Okay? All right. Now, the reason why they're not the same is we're squaring it. So when we square a negative, we always get a positive, which means it acts just like absolute value. Okay? That the principal square root of a squared is the absolute value of a. So we have to be concerned when we have expressions, okay? Because we don't know what the variable could be. Okay? So we use the absolute value signs unless we know the expression being squared is always positive. Okay? So we're going to simplify this using the square root sign. Okay? Now, we know that the square root of 36 is 6. And what letter times itself? T times t gives you t squared, so our answer is t squared, t. Can we guarantee that 36 comes from a positive 6 or a negative 6? No. Do we know that t is positive? No. So we need to put that in absolute value. Okay? So we don't know if the variable is going to be positive or negative. So when we square this, when we square root this, it's just the absolute value of x plus 3 because we don't know if that's going to be a positive or negative number. So we always want to make it positive. Okay, so here we're going to need to factor this. Okay, and again, we don't know if x minus 4 is going to be positive. So I'm going to put in parentheses, or absolute value. Now, square root of t to the 6th, okay, what value of t multiplied by itself gives you 6. Well, that's going to be t cubed, right? Because t cubed times t cubed is t to the 6th. Okay, add your exponents. Okay, so t cubed is our answer. Okay, now, can we guarantee t cubed is going to be a positive number? Nope. So I'm going to put it in absolute values. Okay. I feel like I missed something. Oh, over here. All right, so a to the 8th. Well, that's a to the 4th times a to the 4th. It's a to the 8th. So the square root of a to the 8th is a to the 4th. Can I guarantee that that's a positive value? Yes, because anything taken to an even power is always positive. So I don't need the absolute value sign. Okay, let's try this one. So 3 minus 7. But we're going to put absolute value around it because we can't guarantee it's positive. Okay? So the idea is that can we guarantee that number is positive? If we can't, then we're going to put absolute values around it. Okay? All right, unless we're told otherwise. See, here we're simplifying the expression, assuming the variable is squared is non-negative. So we're going to assume it's positive. That means we don't need to put absolute value. So when we square root y squared, we're just going to get y. A to the 10th would be a to the 5th. We're going to need to factor this. Okay, so that's still underneath the square root sign, which is going to give us 3x minus 1. And n to the 7th. Okay. All right, so in this part, okay, when the number underneath we can't guarantee is positive or negative, we don't know, we're going to put absolute value around it. Now, keeping in mind that when you square root a variable to an exponent, it's basically dividing it in half, okay? Because, I mean, you look, a to the 8th is, square root is a to the 4th. All right, we'll talk more about this. We're going to keep working through it. Let me know if you have any questions, guys, and I'll talk to you again real soon.